Welcome to day 24 of Math 111. We will be looking at operations with integers in the lesson today. First of all, let's look at the set of integers. The set of integers is the set containing the natural numbers, which are 1, 2, 3, and so forth, 0, and the negative integers. So you'll see a representation of the set here at the top of the screen. We want to note that 0 is neither positive nor negative. 0 is also important because it is the additive identity, with the property that when 0 is added to any number, that number is the sum. Also, we need to talk about the additive inverse. When we think about an integer n, the opposite of n is its additive inverse. When we add a number and its opposite, we get 0. When working with operations with integers, it is real convenient to use two-color counters. The two-color counters are round in shape. Each disk has a yellow side and a red side. In the demonstrations that I will be doing in this lesson, I will not be using two-color counters. I will be using color tiles in two different colors. It is important to understand how to use the manipulatives. It is also important to know how to diagram these operations on paper. I will be showing you both. When I am working with the operations with the integers, you'll notice that I will use the expression the cloud. The cloud is just a place where the manipulatives or the counters will be when I'm not using them. You'll also hear me talk about zero pairs. A zero pair is a pair of counters with opposite colors. One counter will represent +1, and the other color will represent -1. When these are added, the result is 0. Therefore, we call them zero pairs. You will see as the demonstrations take place. We will begin with addition. Remember, when we show addition, we build both add-ins. In our demonstration, +1 will be represented with a yellow counter. -1 will be represented with a red counter. So we will begin by building both add-ins. After we've built the add-ins, if there are any zero pairs, we'll move them to the cloud. The remaining counters should all be the same color, and this will represent the sum. I'm going to demonstrate these 4 addition problems one at a time using the counters. Follow along as I demonstrate. Before we begin with the operations with integers, I'd like to show you the cloud. This is my pile of counters that I'll be using in the operations that we'll be working with. I'll slide the cloud off to the side. And we'll look at our first problem. 3 + 4. I should mention that our yellow counters will represent the positive and the red counters will represent the negative. So each yellow counter is +1. When adding, remember, we build both add-ins. So 3 is 4, and the sum is 7. Remember, we are combining the add-ins to find the sum. Our next problem is -2 + -3. This is an addition problem. We build both add-ins. Each red counter represents -1, so we'll have -2 and -3 And so I see I have 5 red counters here. That represents -5. For our next addition problem, I've got it stated 2 different ways. -4 plus 2. We could also see a problem where the positive comes first, 2 plus -4. In either case, we build both add-ins. I'm looking at the top line. So -4. I'm adding 2. I have 4 red counters, 2 yellow counters. And now a red and a yellow represent +1 and -1. That makes a 0 pair when added together. I have 2 0 pairs. The 0 pairs go back to the cloud. This leaves me with 2 red counters. That represents -2. So the sum is -2. Here we have -2 plus 3, or you could possibly see a problem in the order 3 plus -2. With addition, we build both add-ins. One of my add-ins is -2. I have +3 for an add-in. I build both of these add-ins. Remember that -1 and +1 add to 0. So I have 2 0 pairs here. The 0 pairs go back to the cloud. This leaves me with the 1 yellow counter, which represents +1. The sum of -2 and 3 is +1. What you see here is a pencil and paper diagram of the operations that were just performed with the counters. Let me walk you through each of these so that you can understand what is going on. The first problem is 3 plus 4. We are adding 2 positive numbers. We build both add-ins. Yellow, remember, is positive. I lay out 3 yellow counters. I also lay out 4 yellow counters. For the 3 and the 4 are the add-ins. My sum is just represented by the number of counters that are there before us. In the diagram on the right, I'm adding 2 negative integers, -2 plus -3. Remember that the red counters represent the negatives. I diagram both add-ins. I have 2 red counters for the -2. I have 3 red counters for the -3. Since there are no 0 pairs, then the sum is represented there with the 5 red counters. Moving on to the next 2 addition problems. The first one is -4 plus 2. Again, I represent both add-ins. -4 is represented with the 4 red counters. 2 is represented with the 2 yellow counters. I have 0 pairs now. A red and a yellow combined make a 0, and I move the 0 pairs to the cloud. Notice how I've circled the 0 pairs and draw arrows to the cloud. The remaining 2 red counters represent the sum of -4 and 2. Since red represents negative, then I have a representation of -2 for the sum. The figure on the right is the representation of -2 plus 3. Again, this is an addition problem, and so I represent both add-ins. -2 is represented with the 2 red counters. +3 is represented with the 3 yellow counters. I have some 0 pairs. Notice that I circle the 0 pairs and draw an arrow from the 0 pair to the cloud. The 1 remaining yellow counter represents the sum. The sum is -1. The next operation we want to consider is subtraction. For subtraction, we build only the menu end. Again, we have the color designation here. +1 will be represented by a yellow counter. -1 will be represented by a red counter. And we think of subtraction in terms of the takeaway model. We'll actually take away the number of counters designated by the subtrahend. If we don't have enough counters to take away, we'll bring down some zero pairs from the cloud so that we do have enough to take away. And finally, the remaining counters should be of one color and will represent the difference. We will consider these 6 subtraction problems. Follow along as I model these with the counters. Now we have some subtraction problems. Think of the takeaway model whenever you encounter a subtraction problem. With subtraction, remember, we build only the menu end. 5 minus 3, 5 is the menu end. It's a +5. So I need 5 counters here. And then I take away 3. 3 are going back to the cloud. I'm left with 2 counters. 5 minus 3 is 2. Here we have a similar problem. The menu end and subtrahend have traded places. I've got 3 minus 5 now. We build the menu end, which is 3. I need to take away 5. I don't have 5 to take away. I'm going to bring down some pairs from the cloud. So here's one 0 pair, and here's another 0 pair. Now I have 5 that I can remove. I'm going to take away the 5 positive counters. This leaves me with the 2 negative counters. 3 minus 5 is -2. Just to review, I needed to take away 5. I only had 3 counters. I went to the cloud and brought down 0 pairs, and then I was able to take away the 5 yellow counters. -6 minus -4. The menu end is -6. I need 6 of my red counters. I'm taking away 4 red counters. Take these away, and I'm left with 2 red counters, which represents -2. This problem looks similar to the previous one. However, the menu end and subtrahend have traded places. A menu end is -4. I need to take away 6 red tiles. I need to go to the cloud and bring down some 0 pairs. There's one 0 pair. And here's another 0 pair. I'm taking away 6 red tiles. That leaves the 2 yellow tiles, which represents +2. Our next subtraction problem is -2 minus 3. The menu end is -2. I'm taking away 3. I don't have any yellow tiles to take away. I'm going to go to the cloud and get some 0 pairs. And now I have 3 tiles I can take away. I'm going to take away the 3 yellow tiles. I'm subtracting a 3. And so I'm left with 5 red tiles, which represents -5. My next subtraction problem is 2 minus -3. The minuend is +2. I need to take away 3 red tiles since I'm subtracting -3. Since there are no red tiles there, I'll go to the cloud and bring down some 0 pairs. There's 1. There's a second 0 pair. And then a third 0 pair. I'm taking away 3 red tiles because I'm taking away -3. This leaves 5 yellow tiles, which represents +5. We want to demonstrate now how this would look diagrammed on paper. Let's take these subtraction problems one at a time. 5 minus 3. Remember, you represent only the minuend. So I represent 5 counters here. This is a +5, so I have 5 yellow counters. And I'm taking away 3. So notice I circle 3 counters and draw an arrow to the edge of the page. This represents taking away. The uncircled counters represent the difference. So I have 2 yellow counters that are uncircled. 5 minus 3 is 2. In the second example here, I have 3 minus 5. In the figure on the right, you'll see this. I begin with the minuend, which is 3. So I draw 3 yellow counters. I need to take away 5 yellow counters. Since I don't have 5, I'll bring down some 0 pairs from the cloud. I'll bring down enough so that I have 5 yellow counters that I can take away. So you see I've brought down 2 0 pairs from the cloud. I circle 5 yellow counters and draw an arrow to the edge of the page. The 2 red counters remain. This represents the difference. And remember, red represents negative, so this represents a difference of -2. Next, we want to consider -6 minus -4. The minuend is -6. I draw 6 red counters. I want to take away 4 red counters since I'm taking away a -4. I just draw a circle around 4 of my red counters and draw an arrow to the edge of the page. 2 red counters are left, and this is the difference. So -6 minus -4 is -2. Our next example is -4 minus -6. You'll see this diagram on the right. I begin with a minuend, which is -4. So I draw 4 red counters. I need to take away 6 red counters because I'm subtracting -6. In order to do this, I have to bring down some 0 pairs from the cloud. I bring down enough so that I have 6 red counters to take away. So you'll notice that from the cloud, I've got 2 0 pairs. I then circle the 6 red counters and draw an arrow to the edge of the page. This leaves behind 2 yellow counters. The 2 yellow counters represent the difference. That's a +2. So -4 minus -6 is +2. We have 2 more examples here. -2 minus 3. The minuend is -2. I begin by drawing the 2 red counters. I'm taking away a +3, and I have no yellow counters there. I bring down 0 pairs from the cloud. You'll notice I brought down 3 0 pairs so that I can take away 3 yellow counters. I circle the yellow counters and draw an arrow to the edge of the page. I'm left with 5 red counters. This represents a -5. The difference, -2 minus 3, is -5. In the diagram on the right, you'll see 2 minus -3. The minuend is 2. I begin with 2 yellow counters. I need to take away 3 red counters since I'm taking away a negative number. I need to bring down some 0 pairs from the cloud. I bring down 3 0 pairs so that I have enough red counters to take away. After bringing the 0 pairs down from the cloud, I circle 3 red counters and draw an arrow to the edge of the page. I'm left with 5 yellow counters. This represents +5. 2 minus -3 is +5. The rules for addition and subtraction of integers are summarized in this definition that comes from your book. Notice that m and n are both greater than or equal to 0 in the statements here. The first bullet, m plus n equals n plus m, is your commutative property. In the second bullet, you'll notice that when we're adding a pair of negative integers, it is the same as adding the positive, and then the negative, of course, is outside the parentheses, so we end up with a negative sum. If m is larger than n, then whenever I add m and -n, it is the same as subtracting m minus n. If n is smaller than n, then the sum of m and -n is the opposite of n minus m. So in other words, we're taking away the smaller quantity from the larger quantity and making sure that our sign is negative. And the last bullet is the additive inverse property. When we add an integer and its opposite, we get 0. And here are some properties for addition of the integers. We've seen these properties before, but not applied to the integers. So we have the closure property, which means that when we add a pair of integers, our sum is an integer. We see the commutative property repeated here. We have the associative property, which has to do with the way integers are grouped in addition. The additive identity property of 0. So 0 added to any integer does not change the sum. So 0 plus m is equal to m. And then we have the existence of negatives. And here we've got the additive inverse property again. Let's move to multiplication. For the multiplication operation, we'll think of this as repeated addition. Remember, when we say a times b, that means there are a copies, and in each copy we've got b elements. We'll start with a clean surface representing 0. We'll build the number of copies needed. If a is positive, we will proceed normally. If a is negative, we'll think of this as a takeaway problem. We'll also be using 0 pairs when necessary. We want to look at these 4 multiplication problems. Follow along as I demonstrate these with the colored counters. Changing to multiplication now. Let's look at some multiplication now. I have 4 times 3. This means I have 4 groups of size 3. This is a positive 3, and so I will use the yellow counters. And I need 4 groups of 3. When I count the number of counters that I have here, I see that there are 12. 4 times 3 is 12. For this next problem, I have 3 times negative 4. This means I need 3 groups, each containing 4 red tiles. So here's one group, 4 tiles. Let's arrange them like this. Got another group of 4. And then a third group containing 4. I have 12 red tiles when I count this. Remember, each red tile represents negative 1. I have a representation here of negative 12. For a problem like this, we will start with a blank sheet of paper, which represents 0. There's nothing there. I'm going to bring down 0 pairs. How many do I bring down? Well, 4 times 2 is 8, so that's a good place to start. Bring down 8 0 pairs. And we'll line some up down here. So I've got 8 0 pairs. 1, 2, 3, 4, 5, 6, 7, 8. I'm taking away 4 2s. The 2 is positive. The yellow counters are positive. So I'm going to take away 4 2s. This leaves me with 8 red tiles. The product is negative 8. For this multiplication problem, I have negative 4 times negative 2. Because the first factor has the negative, I will again think of this as taking away. I'm going to start with an empty piece of paper here, meaning 0. Since 4 times 2 is 8, I'm going to bring down 8 0 pairs. Put a couple across the bottom here. I have 8 0 pairs. I'm taking away pairs of negatives. Taking away 4 pairs of negatives. So I'm going to take away 2 red ones, another pair of 2 red ones, another pair, and finally the 4th pair. That leaves me with 8 yellow tiles. Yellow represents positive. I have 8 1s here. This is positive 8. So the product of negative 4 and negative 2 is positive 8. Let's look at these 4 multiplication problems individually. When we think of 4 times 3, we think of 4 copies of 3. This is a positive 3, and so I'll use the yellow counters. So you'll notice in the diagram I have 4 groups of 3 counters. All of these counters are yellow. I can count all of my yellow counters, and I get 12. The product is positive 12. Moving to the next multiplication problem, I have 3 times negative 4. Here I have 3 copies, and each copy contains negative 4. You'll notice that I have 3 groups of red counters. Each group contains 4 red counters. So when I count all of these red counters, I have 12 red counters. So the product of 3 and negative 4 is negative 12. Here we want to consider when A is negative. I have negative 4 times 2. I'm going to think of this as a takeaway problem. So remember, you start with your clean piece of paper, and that represents a 0. And I'm taking away 4 times 2. Since I have nothing on my paper, I need to bring down things from the cloud. So I have to bring down 0 pairs. I will bring down 4 pairs. So you'll notice I've got these grouped up. I'm taking away 4 2s. So I'm taking away 4 pairs of yellow counters. I circle the yellow counters and draw an arrow to the edge of the page. All of the red counters are left behind. When I count these, I've got 8 red counters. The product of negative 4 and 2 is negative 8. Moving to the next problem, you'll see the illustration on the right. Negative 4 times negative 2. Again, I'm beginning with a blank piece of paper, and I'm thinking of taking away some things. So I'm bringing down 0 pairs from the cloud. I need to bring down 4 pairs of 0 pairs. So that means I'm taking away 4 pairs of reds. So I circle the red counters. Notice that I've got 4 pairs of red counters in the circle, and I draw an arrow to the edge of the page. This leaves 4 pairs of yellow counters. This means there are 8 yellow counters. The product of negative 4 and negative 2 is positive 8. We have the rules for multiplication defined here. M and N are positive integers in the definition here. And so negative M and negative N are negative. When I multiply M and negative N together, my product is negative. It's negative M times N. When I multiply negative M and N together, the product is negative M times N. And when I multiply negative M and negative N together, I get a positive product. The product is M times N. When the signs are the same, the product is positive. When the signs are different, the product is negative. We have multiplication properties of integers here, and we've seen these properties before in a different place. We've got our closure property, and this simply means that when 2 integers are multiplied, then the product is also an integer. The commutative property, R times S equals S times R. The associative property, which has to do with the way the factors are grouped. We have our distributive property, R times the sum of S and T is equal to R times S plus R times T. 1 is our multiplicative identity. So 1 times R is equal to R times 1, which equals R. And then we've got this multiplication property of 0. 0 times R equals R times 0, which equals 0. We want to think just a moment about division. Integer division is defined in terms of multiplication. It is the inverse operation. So notice the definition here that comes from your book. If A, B, and C are integers and B is not 0, then A divided by B is equal to C if and only if A is equal to the product of B and C. So again, notice that division is defined in terms of multiplication. Notice also that b is not equal to 0. We cannot divide by 0. And here are the rules for the signs when we are dividing integers. In the rule here, m and n are positive integers, and so negative m and negative n are negative. When a positive is divided by a negative, then the quotient is negative. You'll see that in the first two bullets. And the last bullet tells us that when a negative is divided by a negative, the quotient is positive. I want to emphasize something that I said just a moment ago. Division by 0 is not defined. 0 cannot be a divisor. 0 can be the dividend in a division problem. And remember, we have dividend divided by divisor is equal to the quotient. So 0 can be the dividend, but 0 cannot be the divisor. This is very important. Let's look at why division by 0 is not defined. Let's think of how division and multiplication are related. 8 divided by 2 is equal to 4 because 4 times 2 equals 8. We can look at more examples. 12 divided by 4 equals 3 because 3 times 4 equals 12. I'm going to skip down. 0 divided by 7 is equal to 0 because 0 times 7 equals 0. But if we try to put 0 in the divisor position, 7 divided by 0, then what does this mean? What would multiply by 0 in order to give us 7? There's nothing that works here. So this doesn't make sense to us. So division by 0 is not defined. This is very, very important. So in wrapping up, students need to work with integer operations until they get comfortable with them. It's very important that they understand the signs as they work with addition, subtraction, multiplication, and division. Knowing the rules is important, but having a working knowledge is one key to success. So giving them tools to work with will help them as they learn how to operate with integers.